These are the notes 8.2, Day 2, parallelogram and the converse. Today we're going to be looking at the converse of proving parallelograms. A parallelogram is a quadrilateral with both pairs of opposite sides that are parallel. Our converse means switch. Today, we're switching the hypothesis and the conclusion from yesterday. Let's see what that looks like. If AB is parallel to DC and AD is parallel to BC, then ABCD is a parallelogram. Now, let's take a look at our theorems. I have kind of color-coded them for you so we can see the theorem and its converse. If both pairs of opposite sides of quadrilateral are congruent, then the quadrilateral is a parallelogram. What is that saying? It is saying if AB is congruent to DC, and we see the double markings on those, and AD is congruent to BC, we see the single markings, that means that ABCD is a parallelogram. The next one says, if both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. Okay, remember opposite angles are on the diagonal. They're across from each other. We see that if angle A is congruent to angle C, they are marked with one angle marking, and angle B is congruent to angle D, then ABCD is in fact a parallelogram. Our next converse theorem says this: if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. So let's see what that looks like. First of all, I think I'm going to highlight those diagonals. Here is one, and here is the other. And it says this: if AC and DB bisect each other, that means create two equal segments. Let's look at AC. Here's my midpoint. AE is equal to CE, and in diagonal BD, DE is congruent to BE, then ABCD is a parallelogram. Now we have a bonus theorem today as well. If one pair of opposite sides of a quadrilateral is both congruent and parallel, then the quadrilateral is a parallelogram. That says if AB is parallel to DC and AB is congruent to DC, then ABCD is a parallelogram. Let's now turn over our notes and look at how we're going to work some problems. Okay, the first set says, are the following quadrilaterals a parallelogram? If yes, state the reason. So we're looking at this picture in number 1. I'm noticing that we're evaluating diagonals. Let's mark our diagonals. I've got DF in orange and EG in green. Remember, our theorem states that if it's a parallelogram, the diagonals bisect each other. Well, let's take a look. We've got EG, and we notice that the two pieces, one of them is one hash mark and the other has two. Are those two congruent segments? No. This is not a quadrilateral or a parallelogram. It is a quadrilateral. I apologize. It's just not a parallelogram. Now let's look at ABCD with AB congruent to CD. Let's draw him out. A, B, C, D. And it says that AB is congruent to CD, and AD is parallel with CB. Well, we know in thinking about our theorems that it says that both pairs of opposite sides of a quadrilateral are congruent. We have a parallelogram. Or we can look at if one pair of opposite sides of a quadrilateral is both congruent and parallel, then the quadrilateral is a parallelogram. This picture doesn't fit either of those. It is a mixture. So the answer here would be no. It is not a parallelogram. All right, moving on to number 3. Once again, we have A, B, C, D. And we notice that AB is congruent to BC, or CD, and AD is congruent to BC. We do have two opposite sides of this quadrilateral are congruent. So yes, because opposite sides are congruent, and that's two pairs, it is a parallelogram.